Thank you, Jennifer. Hi, guys. How's it going today? So welcome to Securing the Heart of Automated Infrastructure, or Why Security is DevOps. But before I go into my talk, why security? Like, why are we talking about security right now? Why am I even up on this stage talking about security? Because there seems to be a misconception with security that it's this black box that's pristine, tightly wrapped around red tape that, you have to be worthy to touch, or otherwise you just get an outright no. Or, it has to be isolated and controlled and you can't do anything with it. That's mostly what people think about when they think about security. Or the security people behind it, where there's this scary person and you really don't want to talk to them because you know they're going to say no, but you have to anyway because compliance. And it just seems like there's a misconception that, security is just all negative. But I'm here to talk with you today because I don't believe that it's negative. I don't believe that, it's as bad as it seems. Because really, when we think about security, well, for one thing, it's me. Hi, my name is Jamesha Fisher. I'm a DevOps security pirate, or Viking in the case of this picture. I work at CloudPassage, where I work with our security and tech organization to collaborate to create a beautiful security platform, which many enterprise customers use every day. What I'm here to discuss is why DevOps is security, and give some demonstration of that by showing you some guidelines and considerations you should keep in mind when securing Chef and/or Puppet, or any other server when you kind of think about it on the grand scheme. So keep that in mind. So, one second. Now that I've introduced myself, and I've showed you why security isn't as scary as it seems, why is security DevOps? Well, for one thing, security is in the public eye more than ever. You have brand name vulnerabilities, such as in, not this year, but I think, was it this year or this past year with Heartbleed? It was the first publicly branded vulnerability, as in it had a website, it had a logo, and everybody knew about it. Even people not in tech or familiar with the vulnerability knew about it because of its impact and how wide it spread. For those not in the know, Heartbleed was a security vulnerability that basically exposed SSL certificates, leading the trust that was brought with SSL certificates basically in harm. So you never knew if the site you were going to was actually the site due to this vulnerability. So there was a whole lot of patching, there was a whole lot of renewal of certificates, and a whole lot of sites recommended that you change your password. But the interesting thing about it is because this had a name, it spread. The people behind the Heartbleed site, the CEO said, I think that the fact that it had a name, had a catchy logo that people remember, really helped fuel the speed at which people became aware of this. So because people became aware of it, they patched it more. But even then, there was still some patch. Like after 2 months, 300,000 servers were still unpatched with this. So even though there's brand name vulnerabilities and they're spreading out there, you still have the issue of people not patching, which leads to breaches of various industries. Because people know about these vulnerabilities now, because they're so widespread and they're, the news about them are brought through social media, it results in people, or people even without the knowledge, breaching and having data disclosure. And this, in itself, which I'm going to talk about more, leads to digital fraud and crimes. Such a couple examples for that. One example that was really prolific and really hit a major space is the Sony hack. Suddenly, people in the entertainment industry who really, it's not their thing to care about security, suddenly they were being asked, so what do you think about this security thing? What do you think about this Sony hack? And I like how some of them realized the impact on how it wasn't just a security hack, but it's something that impacts their lives. Like I read something from an interview of Angelina Jolie, and they were like, well, what do you think about, this email getting disclosed between you and them talking about, your job and your salary? She's like, I don't really care about it, but I am worried for that person because this person has kids. And this just happened while, they were on the job. They could lose their job. So it has that real life impact. Or more recently, the Ashley Madison hack, and how even though people may have differing of opinions, that still impacted real lives. And in this case, one man who apparently had used the site, but he was a closeted gay man, and suddenly was in Saudi Arabia and was like, I need to get out of here because if this information gets disclosed, I may lose my life. So even more seriously now, we need to be ever more vigilant when thinking about security because it does affect people. It does affect people's lives, and the news does spread when a breach happens. Another thing to keep in mind about security, the concerns that security people have really match up well with DevOps. And to give you a demonstration of that, I have the Security Triad. It's something that I learned in school and something that's still used. It's still in documents based off of security and compliance. So I'm gonna walk you through this and show you how each of them are connected to DevOps. And this is something we're also going to use for the rest of this talk, so keep it in mind. First, we have availability. And it is, in the security world, the definition would be for any information system to serve its purpose, the information must be available when it's needed. So what does that mean for us in the DevOps world? Well, it means that it has to be fast. Fast, that we get our product or our platform or what have you, get our software to the customer as fast as our resources allow it. It also means that we recover from issues, whether it's an outage due to failure or a security incident. But it also means throughout those incidents that we ensure uptime. Excuse me. So that means ensuring high availability when these incidents happen, or monitoring beforehand, like Betsy brought up earlier, so we can catch these incidents before they happen and proactively prevent incidents from happening or prevent the incident from spreading large enough where the customer notices. Excuse me, I'm just checking my notes. Then you have integrity. And the definition for that is that a system and its data are not manipulated for unauthorized functionality or alteration. So what does this mean for DevOps? Well, it means making things repeatable and standardized. And that's the automated, that's the way of automation that we have, right? Is that if we have a process that we have to repeat over and over again, we're gonna make sure that it's repeatable and that we can standardize it in a way that everybody can understand and use. But another reason, especially for security, that this is important is that it allows things to be auditable and processed. So we're able to figure out anomalies quicker and faster. We're able to figure out, okay, all of these servers, since they're in the same pattern, we need to patch them in the same way. So it's really important we keep that in mind when we're setting up and configuring a system. And then finally, we have confidentiality. And this is the tough one because it's the requirement that private or confidential information not be disclosed to unauthorized individuals. So what does this mean for DevOps? Now, usually when you talk about confidentiality, that means, okay, these people cannot touch, customer data, or there's certain data that they can't have, or there's certain access that they can't have. And so this is probably one of the hardest, but at the same time, I sincerely believe that confidentiality can still happen as long as we're even more collaborative than we usually are. There is a way that we can still create controlled environments that are not siloed. And also, in addition to that, we can also pull everybody into the security process without data disclosure to our customers. So with all those principles in mind, why is this so important for the deployment of Chef or Puppet services or any of the tools that we use? The reason why is that different objectives for software needs to be met securely. Like, that's the reason that we have compliance and stuff in place. And this requires the work of many different teams. So the tools that we use, especially that's central for us building a product or building the infrastructure around it, they need to go through the same process that we use for our application code. So by having it go through that process, we ensure that there's security with the tools that we use as well as the code that we make from them. So now that we've talked about why security is important in the DevOps process, let's go through some considerations, starting off with planning. And let's talk about availability with planning. So when it comes to availability or setting up a server, you have questions that you ask, like, how many nodes do you plan to have? Are you cloud or bare metal? What do you plan to do with these services? And how quickly do we need to recover? For the security people, the biggest consideration that you need to have is, how quickly do we need to recover? It's especially important, and it's in a lot of compliance, on how quickly you can come back up from an incident and/or failure. And especially when using tools like configuration management services like Puppet or Chef, you need to consider the risk. And the two easiest questions I can tell you to ask when you're considering risks, or the two major questions, though there's other ones, is how long can the service be down for? And where are you backing up and replicating, if at all? Those two questions. Like, you have the other ones, but those two are important. It's like, are you doing high availability, or are you just backing up incrementally, and then you have a way to automatically spin something back up? And then how long can you be down for? How long can the system stand to not be, disconnected from Chef, Server, or Puppet? And that can vary depending on your uses of the system. For some, for instance, like at Google with Puppet, you could be disconnected for a bit, but it would still record it and know. In our case, for Chef, we wanted to use high availability, but the infrastructure we have is cloud-based. So that means we're mostly in the cloud, and the high availability, at least as far as I know at this moment, for Chef, uses distributed replication block device, which means that it has to have close connectivity and it's very network intensive. So that's kind of poor for the cloud unless you're using private cloud. So instead, at the current scale that we had, we decided to just go with automated, having backups and then, automated builds of the infrastructure back when we have issues. But this, of course, may change as our company grows, as our technology grows. And so that's one thing you should additionally consider, that risk always changes with your technology. So moving on, the next thing in talking about planning is integrity. And some questions you should think about when considering integrity is, one, how do we configure the servers? And this can be in many different ways. There are many different ways to shave a yak, as they say. And you can automate it if it seems feasible. Again, is the risk worth the effort? And this can either be with Chef or Puppet. Especially when you're first starting it up, you may go with, a Chef recipe with Chef Client Local or Chef recipes. If you're migrating from an old server to a new one, you may set up the new infrastructure through the old Chef server if you're migrating. Or you can do Puppet masterless if you're in Puppet land. I've even seen instances where people spin up servers and start them up with Ansible and then add Chef and Puppet later. I've seen that happen. So there's plenty of ways to configure. Two things you need to keep in mind specifically for Chef and Puppet people is the configuration of SSL and firewalls. With Chef, starting with Chef Enterprise 12, which was released late last year, and the current thing that my company and a whole lot of others use, that has SSL by default. So if you're trying to be really, really secure, especially with hosted Chef, and you're doing it on premise, you have to make sure that that's configured. There's also for Puppet. For Puppet, it has I think certificate authority, and it has a certificate authority, but there's only one, so there's a scalability issue there, but that's something to keep in mind as far as SSL. For firewalls, for either of them, you want to make sure that you have rules in place for inbound and outbound. A whole lot of people have rules for inbound in documentation, but a lot of people don't consider the outbound considerations. And that might be a no-brainer for some, but in security, it's something that you have to be careful with. It also takes a bit of time. Like, we had some issues with that in not only doing outbound, but also setting up stuff for loopback when we were first setting up the new Chef infrastructure. So make sure to have services open on loopback. The next question is, how do we ensure standards and security? Again, that's also multiple ways to shave a yak. Using different type of tools, whether it's Puppet plugins or Chef Audit and soon to be Chef Compliance. But those shouldn't be the only things you should use. You shouldn't use just your tool in order to audit security, because what if that tool goes down? You want to make sure, as the security people like to call it, have defense in depth. You want to have redundant checks to verify the false positives that you may get with some of your tools. And you also want dedicated resources for checking for software and whether it needs to be patched, or checking the configuration security based off of compliance rules. For us, we eat our own dog food. So I use our security platform, CloudPassage Halo. But there's other tools out there for use in monitoring. So now that we've talked about availability and integrity, let's talk about confidentiality. So the questions that we want to ask. How do we want to structure our services? And this is kind of more of a Chef thing, because there's two ways in the Chef world. You can either have it all in one pot if you're using hosted Chef, or you can have different organizations. When I had to think about this when deploying Chef Server, I had to think about the pros and cons. For the org base, for us, there was a clear separation if you really needed it for the isolation. And it's nice if you're a service-based company and you're trying to provide things for different companies who kind of want that isolation. But the cons is that you then have to think about workflow and how to involve everybody and to make sure that, the testing environments are getting what they need and everything's getting updated. So it's the same. So it's the same in each environment and everything's up to date. This might be easy if you're in Berkshelf land, because Berkshelf usually packages the cookbooks. And Berkshelf is for Chef, by the way. It's a tool that's used. So Usually with Bookshelf, you can package all the cookbooks up and they have locks so you can more easily manage and make sure every environment or organization is on the same page. But again, it's planning to get that done. And then you have just everything in one org, and then it's based off of environments. It's easier to manage in one bucket, but you also have to do more auditing in place, which is what we ended up doing. Having a whole lot of auditing in place depending on whether we were managing production environments or non-production environments. And usually when somebody makes a change, you have to make sure they're on call or they get permission, and we have everything referenced by a ticket. So if everything doesn't have a ticket, pretty much the operation won't go through. So there's a whole lot, there's different checks and balances depending on which route you go. The next question is like, how are you going to deploy how are you going to deploy? Are you going to deploy a new service fresh? And if so, how are you going to migrate the machines over from not being managed to being managed? Or are you going to migrate from a newer version, from a older version to a newer one? So how is that going to go? How are you going to migrate from the old host to the new host? And how are the hosts that are currently being managed going to be managed by the new host? These are some questions you want to consider. And then how are users going to access? So in the Chef world, two things. One thing to consider is that you want to use always user. Because if you use a client and then you migrate over to a user, that apparently breaks things. I found this out the hard way when we started migrating and some of the admins couldn't get work done. And you also have more accountability when you have user management, especially in Chef 12. For Puppet, they use whatever's on the server by default in terms of uploading stuff. They also use LDAP integration, so Chef has it too, but it's still not as integrated as we'd like it to be. But those are two things to keep in mind. Also, another consideration to make is role-based access. What should it be based off of? Should it be limited to just environments, or should it be limited to roles, whether you're in QA or dev, and what permissions they have? Those are some things that you can consider as well. So now that we've talked about considerations that we're making in planning on availability, integrity, and confidentiality, let's talk about testing and what guidelines you should keep in mind for that. I like to call it the prep and practice of the firefight as well. So with availability, pretty much steps are simple. It's building the host and setting up the server, no brainer here, but it's also ensuring that it's set up in the closest way possible to how you want it to be set up or how you would use it. You would ensure the minimum authorized users can log in and test basic operations in worst cases, and pretty much those worst cases include failure. A whole lot of people don't test failure and whether the failover that you set up in Chef High Replication actually works. So that's something you should keep in mind when doing setup. As far as integrity, you should check software vulnerability management and configuration security monitoring for consistency. So again, checking for those patches, both when you first set up the server and after you set it up and after you've patched. You should do that continuously. You should verify that the firewall rules work. Make sure the SSL is valid and set up. And then for confidentiality, you should create the organization or role-based structure that you have set up, including the users, and test authentication and basic operations. I'm sorry, I'm speeding through right now because I just got the signal that I'm slow on time. So I'm going to go through the demo slides real quick, and then I'm going to go just straight to the end. So this is just the integrity part because this is the security part that's essential to me. Can you guys see that okay? So pretty much the important thing to keep in mind is the bottom half where it has all the SSL certificates. This is just specifically for Chef. Again, keep in mind how there's Nginx setups. So you have the etc PKI, the location of the certificate and the key, and also the specifications for the country name, the state name, locality, company name. This is stuff you have to manually actually set up, otherwise it goes by the self-signed cert by default. Then considering the setup for firewall management, that's our little interface there. Those are the firewall rules. I know these are really, really simple, but this is just bare minimum. I'd be more detailed if you want to go into that, but this is just an example. Then there's software risk. This is showing, again, the process of what we have when we first set the server up, and then after a similar server was set up and patched, how you just have the kernel update, again, showing how it can be continuous. So, in conclusion, with availability, you should plan for recovery and test setup and basic operations at least. You should also include worst-case scenarios and always plan and test for failure. Integrity, plan for the repeatable and enforceable, and check for security, always. In confidentiality, plan out user organization, and including users and roles, and test for operability. And that's it. Thank you so much.